It helps us in planning for the population. It helps us in planning for individuals. So it is very, very, very important. Statistics is very, 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 very important because it really helps us to plan in projection. It helps us in planning for a specific size of the population. It helps us in forecasting. It helps us in quality control. Look at it. So, for example, if I come to your facilities, there are some standards that you guys have set for yourself, and based on statistics, you are able to know if you are meeting those quality standards. So much. Okay. So that's the relevance of statistics. That statistics is very, very, very relevant for you guys. Okay. And so I've highlighted some instances that statistics is used. You know, there are some instances. These are some instances that statistics is used, as you are seeing on the screen. So this is what I'm so much concerned. As for this AI and these things, I'm so much concerned about this time. The study of statistics can help you to make more critical in your analysis of information, so that you are not misled to accept deceptive claims. You get it? So based on statistics, you are able to analyze things, and then you are not misled to accept deceptive claims. Some people make some claims, and these claims may not be right. They are just claims. So the claim can be either right or wrong. So you don't just accept it. Okay. So these are the reasons why we study statistics. Okay. I have an exercise here which I'll give it to you for today. Today I'm going to give you an exercise. Okay. So so with respect to the inferential statistics, what we are saying, we are able to generalize based on the small part of that information that we've gathered. We are able to draw conclusions. So if you remember when COVID started, initially they didn't know anything about the symptoms, right? They didn't know anything about the symptoms, but as time goes on, when they gathered information about a whole lot, you know, when it comes to the world, we have all the individuals experiencing COVID. That is the population. You get it? But after they gathered some sample, and then they realized that almost all these the sampling units that they took, each person is experiencing, let's say, high temperature. Each person is experiencing, let's say, cough, so on and so forth. And so now they can now generalize it that, oh, okay, if you have COVID, then you are going to experience high temperature. There's going to be cough. But it doesn't necessarily mean that every person will experience that. Am I lying? You are health personnel. Tell me, am I lying? Is that not the case?
No, please.
Yeah. Is that not the case? So now, that is why. So that is what we refer to as inferential statistics. What they did is inferential statistics. You make inferences about the statistics. The statistics that you've got, you make inferences about it. And so that is what we mean by inferential statistics. That is why now people are saying that if you are getting older, your risk of dying when you contract COVID is very high, because they've realized that those with high age, I mean the ages from 60 and above, most of them died. So based on that, they are able to generalize. They are able to make inferences. They are able to generalize that. They are able to draw conclusion that when your age is about 60, the likelihood of you dying when you get COVID is very high. You get it? So that's what we refer to as inferential statistics. I hope I've explained this better now. Resume. Let me resume the class. Okay, so what I'm saying is, when we say population, what we mean is a complete set of entities being investigated. So the complete set of entities, it depends on what you are dealing with. It depends on the phenomenon that you are dealing with, what you are dealing with. And so that one will tell you your population. So when you take complete set of these entities, that is what we refer to as population. For example, all people living in Ghana in 2010, all people, all, you see that here it's all people living in Ghana. You get my point? All people living in Ghana. Do you get it? Okay, so that is it. And then we also, sorry about that, I needed to attend to some. And also, another example is all midwifery students in Ghana. All midwifery students in Ghana. And the last is all the hospitals in the central region of Ghana at any point in time. And so on and so forth. So when we say population, it's a complete set of entities being investigated. And then when we say elementary units, when we say elementary unit, it means that each item in the population that we are studying, or each item in the population, is also referred to as elementary unit. And so, well, for example, if I say all midwifery students in Ghana, then you guys are all elementary units, because you are each individuals in the population. You get it? So elementary unit is referred to as individuals item in the population. Okay. And for example, the elementary unit are persons, hospitals, health workers, students, so on and so forth. Okay, and tables. You see, I have tables here. So if I'm studying tables, that means all these tables are elementary units. Okay. Now, when we say observations, we say observation. An observation is the result of observing an elementary unit. An observation is the result of observing an elementary unit. So when I say, for example, if I'm concerned with midwifery students in Ghana, so when I record one midwifery student, I'm making observation. Do you get my point? So that's what we refer to as observation. And then when we say population size, the population size is the number of all the entities that are under study, the total number of all these entities that are under study. For example, if I'm studying all midwifery students in Garden City University, and let's say the total number of midwifery students in Garden City University is, let's say, 300. Then it means that my population size will be 300. Okay. So that is an example that I've placed here. Suppose that students' population of GCC Nursing College in 2012 and 2013 academic year was 1,000. Then you write N equals to 1,000. Normally, we represent the population size by big N, capital N. So whenever you see capital N, that's what we refer to as the population size. Okay? Are you guys okay? Whenever you see capital N, that is what we refer to as population size. So normally, we represent population size by capital N. Okay, so when we say sample, sample is part of the population under study. Sample is part of the population under study. And so when, for example, you see, when you go to the laboratory, they tell you to go for your blood sample, right? They tell you to go for your blood sample. That's part of your blood to represent everything. So sample is just part of the population that is taken to represent the whole population. So that's why when you prepare soup, when you are tasting the soup, you don't just pick everything and swallow it. You just take a portion of the soup. You just take a portion of it, a portion of the soup to represent everything within the soup. And so a sample is just part of the population under study. And then when we say sample size, it's the number of elements in the sample. Sample size is just the number of elements in the sample. Okay? And so, for example, if we have a population size of 1,000, and then we select 400 students from this 1,000. The sample size is given as 400. That and normally represent the sample size by small n. Okay, we normally represent the sample size by small n. Okay, please, I hope you guys are okay. Let me pause here and take questions. Let me pause here. Okay. So what I said was parameter is whatever characteristic that we compute or we obtain from the population. That's what we term as parameter. Whatever that we compute from the population is what we refer to as the parameter. So what I was saying is, for the parameter, when I pick, for example, if I compute the mean for the whole population, it's referred to as the mean population. I mean, the population from the mean, and that is what we refer to as a parameter. You know, because this characteristic is computed from the population. On the other hand, if I compute the mean from the sample or any characteristics from the sample, it's referred to as statistic. And this statistic always end up estimating the parameter. And don't forget that the parameters are from the population. Okay, the parameters are from the population. Give me some few minutes. I need to give me some few minutes. My dear sisters, now let's move on to what we refer to as variable. You'll already be hearing this thing a lot. Variables, variables, variables. And so when we say a variable, it's just a phenomenon or characteristics whose observation differs from responses to responses, or it differs from one individual to another. It's just a phenomenon or characteristics whose response differs from a person to a person. For example, if I'm so much concerned, let's say age, you see that the age of Mr. Bufa will be different from his son. And the age of my father will be different from that of my uncle. But at the same time, I'm referring to age. You get it? And then if I'm talking about variables within the data, for example, if I come to your class, let's say maybe class 2022, if I want to gather data from the class, you see that if I pick age is a variable because it is going to be different from one response to the other response. For example, if I call, let me call some of you guys. If I call Abdullah Salam Aishetu's age will be different from Abena Sewa, and Abena Sewa's will be different from, I know of Dorcas, I know of Joy Jiwa, I know of Amina. You know, you see, it will differ from one person to the other. But what we are looking at is age. So age is the variable we are talking about. So you see that this thing, it is different from one person to the other, and it is different from one response to the other. And that is what we refer to as variable. So I've given you some example in the lecture notes, which you can see on your screen now. Okay. So these variables, we have, can someone give me a variable here with respect to your class? One person, if you don't talk, we don't continue. You are going to stay here. So you can unmute yourself and then talk. Unmute yourself.
Sir, please complete me. Let's say how I look on first somebody will differ from our colleagues on somebody will be dark, somebody will be somebody will be chocolate.
Yeah. Angie, I can't hear you. Probably your earpiece is so close to your mouth.
Please, I was using completion as an example. That supposing if I take the completion fair, if I'm fair and there is somebody calling me, maybe she might be dark, somebody might be chocolate, so it may differ.
Okay, so what is the variable here? Give us the variable name.
Completion.
Okay, that's good. Good. Any other? Any other?
Hello, sir. Please, an example is height.
Height.
The variable will be height.
Okay. That's good. Height. That's good. I want the last person. The last person.
Hello, sir.
Yes, I bet that.
Sir, please, can we say location?
No. Are you asking us? We just want you to tell us. Don't ask us, please.
Okay, location.
Location.
Yes.
Okay. That's so the variable name is location.
Yes.
Angela's location will be different from my location.
Yes, please.
So let me pause. So you see that all these things that you guys mentioned, it varies from one response to the other response. You know that this time around I'm using response because in most cases we interact with this, and in most cases you use questionnaire to gather these variables or this data. Okay, and so you see that in pertaining to your class, now you've gathered about 3 variables. Someone mentioned height, someone mentioned complexion, someone mentioned location. Okay, do you get it? So that is what we refer to as variables. And so these variables, we can classify them into 2. You have what we call the quantitative variables, and then we have qualitative variables. And quantitative variables are numerical in nature. And so let me just summarize this thing. So quantitative variables is one whose observation varies in magnitude from responses to responses. So the magnitude here, I tell now that it is numeric. So quantitative variables are always numerical in nature. So the value that they can assume is always numeric. Quantities, amount, whatever, number of people, number of children, number of patients, the amount that you receive, your salary, that volume of water, quantities, all these things are numeric, and that's what we refer to as quantitative variables. Okay, and so for these ones, okay, let me pause here. Now let me explain that of qualitative variable, and I'll ask this question. So now that we have quantitative variable, then it means that we can also get quantitative data, because don't forget that data contains variables. Every data contains variables or a variable. And so that means that we can have a quantitative data. And so that implies that if your data set contains quantitative variable, then that is referred to as quantitative data. Okay.